Okay, so today we're going to talk about and recap on our bell ringer, the metals versus nonmetals. When we look at these, the first three items up here are properties of metals. Ductile means you can form a metal into a thin wire, such as if I go to Lowe's and I buy a spool of copper wire, that means that copper was formed into that wire. Francium is in column 1A, which is where the metals are located, and it's actually the most violent reactive metal there is on the periodic table. The left side of the periodic table, which is the largest chunk of the elements, is also identification where metals are located. Fluorine on the opposite side is in group 7A, and that is where the fluorine is where nonmetals are. That group later we're going to find out is called the halogen group. And the right side of the periodic table is, of course, nonmetals. All right, so today our big focus is to introduce you to where families and groups are located on the periodic table. Families and groups are our columns. Remember, columns up and down. Periods go across. Columns are our groups or families, as noted. You see this on this chart. 1 through 18 are our groups, and 1 through 7 are our periods. So let's start with the very first one, which are the alkali metals. Okay, alkali metals are in the very first group. Notice we do not have hydrogen included. Hydrogen is not a metal, and therefore all the elements in here have one valence electron there in group 1A. So when I note this, every single one of these are right here. They are our metals, alkali metals. Okay, also remember this, alkali starts with an A. Right there, it is an A. So think alphabetically reading from left to right. And francium down at the bottom is by far the most reactive. Okay. The next group is called the alkaline earth. Notice right here there are two words, alkaline earth, two words, and therefore it is group 2A. Now these elements right here are basically elements found in the earth itself. When you look at this one, beryllium all the way down to radon. Okay, oops, let me go back to that slide. Beryllium all the way down to radon that's down here. All of these are found in the earth. Let's look at magnesium. That one's also very popular in the earth, but calcium is a big one, easy one to remember. It's found in your teeth and shells, and it's also found in your bones. Calcium, think about your milk. You're getting calcium to make your bones strong. All right, so the transition metals are these that are in the middle. We'll just identify this group. They are the B elements, okay? So when I look at these right here, it is 3B through 12B. Right in here. They're dipped down. It's those in the middle as well as these two that are down at the bottom. They are your transitional metals. They're usually very colorful. An easy one to view is iron right here. Iron, think of the soil in the Piedmont, is very rich with iron. Therefore, it has that rusty appearance as well. They like to combine with oxygen. All right, the next family is group 3A. They're the boron family. Aluminum, right here, aluminum, or as the British says, aluminium, is the most abundant metal that we find in the earth. Okay, but you can see all these others, but aluminum is the main one we're going to focus. They have 3 valence electrons. It's in group 3A. Okay, carbon's the next one. I always think of diamonds are a girl's best friend on there. And this one right here is definitely, let me see. Yeah, we got red ink here. But carbon right here is up at the top. Okay, here we have carbon, has 4 valence electrons. They're at the very top, and carbon is also known as the element of life. A lot of folks think that oxygen is the element of life because we need it in order to breathe and exist as animals or humans. But actually, carbon is broken down and found in all of us. Okay, also carbon is found in your diamonds, and silicon is another one that's really very valuable as well. Okay. Nitrogen family is next. It's in group 5A. Okay. So when we view this one right here, group 5A, we definitely have 5 valence electrons. And the key thing right here, nitrogen is up at the top up there. It is the main component found in our air. 78% of our combination mixture of air is actually nitrogen. And Mr. Bill, who works at Potash Corps of Aurora, phosphorus down in here, as well as the nitrogen, make up components in fertilizer. Okay? The next group is oxygen. It is the group 6A, has 6 valence electrons. And the most abundant element that we have there is definitely oxygen. You can see right there. Oxygen combines with most everything on the periodic table. It's the most abundant element in the Earth's crust. Okay? Halogens are next. Now this is a weird name, the halogens, but they are called salt formers. So when we look at this one, think of sodium chloride, normal table salt, sodium chloride right there. So the chlorine, whenever you find it, is actually forming a salt. Fluorine, again, up at the top, fluorine. Remember, francine was the most reactive metal. Fluorine is the most reactive nonmetal. That means this tends to want to blend or mix with other elements found on the periodic table. The halogen family is in group 7A, and therefore it has 7 valence electrons. The last one is the noble gases, and they are group 8A. They are actually very stable. Okay, they're very stable. They have 8 electrons in the last shell, except for, remember this one, helium. Remember, helium only has 2 valence electrons. 2 valence electrons. This group right here are very stable. In fact, they are probably not going to blend with anything because their shells are completely full. They are also called the inert gases. So noble gases, inert gases, and these are the most stable elements. Okay? All right. So we will end today, and at the close of today's lesson, I want you to draw the electron dot diagram for these elements. Okay? Thank you very much. I hope you've enjoyed this lesson. Thank you. Bye.